Hello Skibidi Razzlers, today we are going to learn about entropy.
Oh shit, here we go again.
So let's start with an example. Imagine you have a sheet of paper. Now we have decided to cut the paper into 3 pieces. What will happen? The entropy will increase. So what can we conclude from here? A sheet of paper was more neat and ordered, but when we cut it into pieces, that paper became more messy and disordered. So entropy is the disorder in a system, and therefore the second law of thermodynamics states that the entropy in a system will always increase, which in an easier sense means that the disorder in a system will always tend to increase. In the past, the entropy of the system was lower than that of the present, and entropy of the present is lower than that of the future. Now you might ask a question, why will the entropy always increase, and what is the formal definition of entropy? Let's explain this using an example. Imagine you have a box of gas molecules separated by a barrier. All the gas molecules are on the left side. Now what will happen if I open the barrier? All the gas molecules will spread out and distribute evenly. So using this example, as we can conclude two definitions. The gas molecules contain energy and the gas molecule spreads out, so we can say that entropy is the tendency of energy to spread out. The gas molecules distributed themselves evenly as time increased. When we open the barrier, hence we can state that entropy is the number of ways a molecule can arrange themselves, and as time increases there are more ways in which a molecule can arrange themselves in. So this is why we will have more entropy in the future than we have in the present. Entropy is merely a statistical law, not an absolute law, because it can be violated. Let's get back to the previous example. As we open the barrier, the molecules might not even spread out and distribute evenly. The position of the molecules remaining unchanged. So as time increases, the arrangement of molecules didn't increase, and thus the entropy in a closed system decreased. But the probability of this happening is very low, that it will never happen, but there is always a chance it may happen, and so it is a statistical law. Now let's debunk a popular confusion. As the temperature is less in a refrigerator, the molecules will have less entropy, so the movement of the molecules will decrease, and so the number of ways in which a molecule can arrange itself will decrease too, resulting in the decrease of entropy. But here's the catch. Even though the temperature decreases inside the refrigerator, it gives off heat to the surrounding, and this increases the temperature of the surrounding, increasing the entropy in the system. Thus, the second law of thermodynamics is never violated. This also showed that increase in temperature increases the entropy. Now let's get back to the most exciting relationship of entropy, which is with information. Imagine you have a box of two sorts of gas molecules, a blue one and an yellow one, and you have a demon standing on the yellow side of the molecule. There's a frictionless ideal door, and you are given the task to let only the yellow molecules go to the blue side, and the demon has a brain to understand this task. Now you have to let all the yellow molecules go to the side of the blue molecules, so the number of ways the molecules can arrange themselves decreases, and so the entropy also decreases. But no, to understand this task and to open the door, your brain had to gather and process information, and this increased the work done by the neurons in the brain. So the entropy in the system actually increased.